Hello there, I'm Thomas Hatsios, an American pilot flying the Boeing 787-900 to 9 we were made flying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport runway 1449 Lszh localizer landing surround in the cockpit for the pre-takeoff preparation of the quality wings. Boeing 787-900 and Microsoft Flight Simulator X. I'm gonna start setting the cockpit instruments and the functions of the Boeing 787-900 aircraft. I'm gonna start with the primary flight display that displays the airspeed indicator, the airspeed selected from the autopilot flight director, system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, and the target altitude selected from the autopilot flight director, system panel, the vertical rate of climb, the center of the aircraft in 10 hundreds and thousands feet per minute, or the steepness of the trigonometric angles and decrease can climb the descent. We have also the artificial horizon with the altitude indicator, the pitch ladder decrease and the bank angle decrease. We have also the Lszh localizer, the instrument landing system of the runway's threshold antennas we use for takeoff and for landing. The threshold antennas that transmit the radio frequency that is unique for each runway and heading. So it's going to be aligned with the magnetic north pole heading of the runway 14 in Zurich International Airport. We're going to use the 136 degrees magnetic north pole heading, and the Lszh localizer frequency will be received from the onboard antennas of the aircraft, will be displayed in the horizontal localizer and the vertical glide slope. So you can see here the displays. You can see also the runway we're gonna use for takeoff and for landing in Switzerland, the Zurich International Airport, and the runway 14 over here. So we're gonna be having also in the primary flight display, you can see the angle of attack of the. We have the Lszh localizer, the horizontal localizer, the vertical glide slope for the angle of approach, and also we have the Lszh localizer cross glass. We have the flight director cross glass for manual guidance of the aircraft, and the autopilot cross glass for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, the flight mode annunciator with the autopilot and the auto throttle. Later on vertical navigation modes, also the radio altitude above the ground level. We have the HSI, the horizontal situation indicator that displays the magnetic heading and track, also the integrated display of the flight plan. You can see the flight plan, the waypoints we have to fly, in the purple line that connects the waypoints one by one when we set up the flight plan. Also the next waypoint we have to fly in flight. So we're gonna create a flight plan here. Using the flight management computer, you will see displayed in the primary flight display, in the navigation display, and also in the primary flight display in the HSI section below the primary flight display. So you see the flight plan over here and here, and also the horizontal and the vertical here. So this is the horizontal profile of the aircraft as it flies. You can see the airspeed here, the altitude. So I'm gonna show you one by one all the instruments before we go into flight. I will show you and explain you all the functions of every instrument of the aircraft. Then we're gonna make an engine start demonstration, set up the flight management computer. We're gonna make a complete flight, a full manual flight in the end part of the video. Maybe in this flight we're gonna use also the autopilot for display, so you're gonna see how the autopilot of the aircraft works. So we're gonna have the horizontal and vertical. We have the navigation display that displays the GPS position of the aircraft, inertial reference position, magnetic north pole, geographic north pole, magnetic variation depending on where we are in the world. We have also the terrain and weather reflections from the weather radar. You can see the terrain around you displayed with a green, red, and yellow amber color indication. So you can see depending on the distance of the terrain around you, in front of you, or below you, and also the altitude difference from the aircraft. It is higher or lower from the aircraft as it flies. You will see the terrain displayed. We can see also the weather. We can see the terrain map with the airports, where the airports are located. Our own airport, the Zurich International Airport. You can see the taxiways and the runways we're gonna use for takeoff and for landing, the runway length and its heading, so we can guide the aircraft into the runway when we want takeoff, when we are flying and we need to approach and land. So we have also You can see other airports, you can see the navigation aids, the nav aids, the voice stations, ADFs and DBs, the waypoints, the waypoints which are horizontal and vertical navigation fixes, and altitude and airspeed constraints. We're gonna select some waypoints using the flight management computer as I told you over here. So we're gonna create a flight plan or a flight path road. It's gonna be connected with the purple line. You can see also in the navigation display, we can see using the transponder, the ADSB and ADC transmitter receiver. The transponder transmits our frequency, radio frequency to other aircraft and the air traffic control and receives from other aircraft. You can calculate with its computer where the other aircraft is located, the distance from our aircraft and the bearing. You can calculate also the altitude difference from our aircraft, if it is higher or lower, how many hundred thousands of feet is above or below us, also whether the climb or descent with respect to our aircraft. You can also calculate it will show us the other aircraft with a diamond shape up to 14 nautical miles ring away from our aircraft, like 72 kilometers. It can also calculate the velocity closing in between our aircraft and the other aircraft. Will give us a warning from the TCAS system, the traffic collision advisory system, so we will have to make an avoidance maneuver in the air. Also we can monitor other aircraft in the ground, in the taxiways, in the runways when we take off and land. So we have also so you can see the diamond shape in the navigation display, other aircraft. Also we got also you can see also we have the autopilot flight director system panel over here. We have the engines indication. I'm gonna show you how to use all the thrust levers over here, how to activate the thrust commanded by the engines, moving the thrust control here. So I have the side stick also, the Logitech Extreme 3D, which is identical to the Airbus side stick. You can see I have the side stick priority button, the push stop and the autopilot disengage for the Airbus aircraft, and also the thrust control. For the Boeing I have the trim stabilizer also. So we have the trim stabilizer over here, and the autopilot disengage, and the head-up declarer over here. So I'm gonna show you how to use. You're gonna see the computer also that I'm using here. Also the mouse pad I have over here. So I have the mouse pad to control the aircraft. So we have the thrust control over here. We can activate the thrust needed. So we increase the thrust here commanded by the engines. You will see more thrust commanded over here, like the N1, the exhaust gas temperature, also the N2 with the fuel flow, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So all this information is displayed by the FAREX. The FAREX are the full authority electronic control computers, one installed per in the gearbox, dual channel redundancy. If one channel fails, the other takes over control points for the display of the data of the engines. So we have also other things. The FAREX do also other functions, the fuel metering unit, the fuel heat exchange sensors. They can transfer fuel from the fuel tank to the engines, control the fuel valves also, for heating up the fuel in flight, so we won't freeze. We circulate the fuel automatically from the FAREX. So you're gonna see also that, also the lubricant and the oil, also other things I will talk about later. So we have the primary flight display here. So we'll show you how to control the flight controls of the Boeing 787 aircraft using this side stick I have here. So we can climb and we can descend. You can see it's the same flight control principles like in the Airbus aircraft, no difference. So climb, descend, make turns to the right, make turns to the left over here, as you can see. So side stick back and forth is also left and right. turns is the control wheel of the Boeing, same thing, no difference. Also we have the rudder pedals for the vertical rudder over here, and also for controlling the nozzle steering we have the tiller left and right side. Also we have rudder pedals with both sides are interconnected. Also all flight controls in the Boeing aircraft are interconnected, both sides act simultaneously. As you can see, let's use some override force from one side. In the Airbus we have dual input also, and which adds algebraically, or we can use side stick one side priority button. So I'm gonna show you how to use all the flight controls. I will show you also the display here, primary flight display. You can see the airspeed indicated, the altitude, the barometric pressure, vertical rate of climb descent, also the pitch and the angle, the bank roll of the aircraft, the navigation display, the terrain display, also the autopilot flight director system panel. So maybe I will use also for the flight controls we have the horizontal trim stabilizer over here. You can trim the horizontal tail of the aircraft when you fly by pressing this switch here. Is the elevator trim for the Boeing 787 and also Boeing 777, 767, Boeing 737, 747 all have an identical trim switch. So this way you trim the elevator up. This way you trim the elevator, as you can see, down elevator trim, left click down, right click. Hope you like it. This is elevator trim, left click down, right click up. So this way you trim the elevator up, you pitch the nose of the aircraft up. When you fly, this way you trim the elevator down, you pitch the nose of the aircraft down as you fly. Also we have the flaps speeds over here, so very easy to remember. Elevator trim. Also we have the autopilot disengage and the head-up declutter over here. Also you can monitor here in the ACAS in the engine indication, the stabilizer trim position is 4.25 degrees, the rudder trim also, the flaps position over here, the cabin pressurization when we fly also receives pressurizer from the engine, so the APU, also from the outside sources for the Boeing 787. So you can use this pressurization panel to control the outflow valves. You can see forward and aft in the open and the closed position in manual, and the differential pressure will go up to 8 psi when we fly at 40,000 feet. The cabin altitude reach 6,000. So you can see the pressurization here. I will show you later. Now it's in the automatic mode, so we can turn the manual also later as we progress. So now we go for the horizontal trim stabilizer over here. You can see also we have, this goes to the normal. We have the alternate flight control modes over here, nose up, nose down. You can see again is the elevator pitch trim over here, and the cutoff switch for the stabilizer trim for the Boeing 787. So this way you have again elevator trim, left click down, right click up, as you can see. So this way you pitch the nose up as we fly, this way you pitch the nose down. Is similar to the Embraer aircraft. You have, or the CRJ aircraft, you have in the panel parking brakes also over here. We have this panel is the thrust levers. I will show you left and right engine, the speed brakes over here also. The flaps over here position, which is secondary flight controls, also the speed brakes. You can adjust how many degrees you retract or extend. So you have the fuel control also for the left and the right engine, you will see that. So this is a fly-by-wire aircraft, the Boeing 787. It has the flight control computers over here, primary flight control computers. In the auto position over here, disconnect, you can see. We have also the air data computer over here, flight control services, so I will explain you all the functions of the overhead panel also. So this is a fly-by-wire aircraft. It has a flight control computers, like the Airbus aircraft have flight control computers. When they fly, they control the aircraft. Flight controls movement by giving a command to the side stick like this. When we fly in the Airbus, like climb or turn, we can climb like 30 degrees maximum with 1.5 G with the flight controls computers on, or descend minus half G or minus 15 degrees, and also make turns 2.8 G left and right turn, or 67 degrees at maximum deflection if we push the side stick full left, or if we leave the side stick we will go back to 33 degrees, or we can level off also. Also, we control the angle of attack in the Airbus aircraft, so we have 2.8 G left and right turns. The G is the acceleration of gravity. So when we fly, with the flight control computers and fly-by-wire aircraft like the Airbus, we make maneuvers in terms of G acceleration, or we keep level flying, horizontal flying with 1 G acceleration. So this is the function of flight control computers. The Boeing has similar. Also, it's a feature of the flight control computers. We have automatic trimming, the auto trim function when we fly, so they balance the aircraft automatically. They can keep horizontal flying. The Boeing 787 and the Boeing 777 also have auto trim function. So you can see, if you have a failure of the auto trim in the Boeing aircraft, you will degrade because of having hydraulic system failure. The flight control computers will be degraded from normal to alternate or direct low or mechanical backup. So as you can see here, if you have a failure of the hydraulics, you can see left and right engine, electric C1, C2, the rammer turbine. We have primary flight control computers will be degraded from normal to alternate or direct mode. So we have to come down here. We're gonna lose the automatic trimming and also the autopilot function. So we have to come down here. This is for all Boeing 737, Boeing 747, Boeing 757, Boeing 767, Boeing 777, and Boeing 787. We come down to this red guarded switch. You see it says from normal to cut off position. We cut off the automatic trimming. We disengage the auto trim function from the stabilizer trim, the L2 left horizontal, right horizontal. So we use only the manual trim. So we use the automatic trimming. Over here we use only the manual. This is the manual trim. We can press anytime. When we fly, we have manual input of the horizontal stabilizer. Over here in this in the control wheel also we can trim like this. The elevator, as you can see, this is elevator trim, left click down, right click up. So you see again we have the elevator trim. We'll use the autopilot function perhaps when we have no auto trim. So you see stabilizer trim again, how many degrees, 4.5. Rudder trim is 0. The flaps position, you're gonna see also a couple more things over here. So we're gonna see now the outside view of the aircraft. I will talk to you about the new procedures, aeronautical and aerospace engineering, and the rights and principles we need to know for the air transport pilot license, the ATPL license, the commercial pilot license, the CPL. We need to know aerodynamics, aeronautical and aerospace engineering. So you can see also we have an aircraft coming in for landing here, a Boeing 737-800. As you can see, here we have it. It comes for land. Here it goes in the runway. So we'll show you the outside view where we'll talk to you about Newton's physics, aeronautical and aerospace engineering. So you see again the cockpit and the side stick. I have all the flight controls. I will explain the function of the flight controls, showing you the outside view of the aircraft. So we have here the aircraft. You can see we have the thrust from the engines that push the aircraft forward, the jet blast from the engines. We have here, you can see we have the surface area of the wings. We divide the weight of the aircraft over the surface area of the forward wings that produce the aerodynamic lift when we fly from the thrust from the engines. It pulls the aircraft wings up into the air with the weight, so that overcomes the weight that goes down, and also the thrust from the engines overcomes the drag. So this is for a jet aircraft. For turbofan engines, you can see we have on the left and the right wing for symmetrical thrusters, and that and also you can see we have the high pressure compressor and turbine in the back side, and the high speed starters have high speed spool. Also we have the front side with the low speed starters have low pressure compressor and turbine, and the low speed spool. So this is the front fan. Also you can see the front fan has the bypasser here in the back. It bypasses some air with a ratio. We have also the exhaust from the jet engine, the exhaust nozzle and cone here. So we have also we have the fuel lines over here, and the wing and engine got the eyes in the front side. So the fuel lines takes fuel from the fuel pumps and the fuel tanks, left and right wing, also the center tank. So we have the mean aerodynamic chord position here, the when the maximum aerodynamic lift occurs in the forward wings is also the position where the center of pressure is moving back and forth on the top surface of the wings. Also the stall, the airflow becomes detached from the top surface of the wings when we fly. So as you can see, we need to avoid the stall. We monitor here in the primary flight display when flying. You can see the airspeed indicated right now, and we're gonna see the stall speed is gonna be displayed with an amber and yellow indication just below the airspeed when we are flying. So we're gonna have also the mean aerodynamic chord. We have the center of gravity here where the mean aerodynamic chord is. It's also the yawing axis for the aircraft. You control the yaw using the rudder when flying through the center, the vertical center of gravity. So you're gonna see the aerodynamics of flying. Also when we are in the ground, we have the nozzle steering. We can turn the nozzle left and right to control the aircraft directional controls. So we can use from 76 degrees left and right deflection using both the rudder and the rudder pedals and the nozzle steering. It's automatic from the computer, you don't need to do nothing. So you see here the rudder pedals, you move left and right the rudder over here. Also we have the nozzle steering, the tiller. So rudder pedals, also top brakes, you press the brakes when you press the top surface over here of the rudder. So the nozzle steering is controlled from the computer from 76 degrees left and right deflection, from 0 knots up to 72 kilometers an hour or 45 knots. Then the rudder becomes aerodynamically effective when we take off, for instance, likewise. Then the computer automatically decrease the deflection of the forward nozzle from 76 degrees left and right to like 7.6 degrees in takeoff, from 45 knots nautical miles per hour, 72 kilometers an hour, up to 80 nautical miles per hour. We have 7.6 degrees left and right deflection. Then above 80 knots, like 144 kilometers an hour, the computer automatically locks the forward nozzle to 0 deflection, or a very small deflection like 0.5 or 1 degrees. So we have only the rudder above 80 nautical miles an hour or 144 kilometers an hour in takeoff. So the inverse happens in landing. When we land, we have the rudder in flight, and then after touchdown, as we slow down, the nose will come in. It starts moving left and right progressively from the computer. So this is the yaw axis, the rudder pedals we need to know for the aircraft. Left and right turns over here. So we have one more axis here is from wingtip to wingtip. We have the pitch axis. We use the elevator here, also the elevator trim. So in the Airbus you pull the side stick back and forth, push back or push forward. You climb and descend the aircraft using the elevator to climb the aircraft like this. In the Boeing you have the control column over here, the yoke of the Boeing 787. So it's the same flight controls in the Airbus side stick back and forth. In the Boeing is the column back and forth, the yoke. So you take the weight up, you climb, and you take the weight down, you descend. And you have the auto trim also function, the manual trim. So I'm gonna show you also that. This is over here. We have one more. So this is control climb and descent. We have one more control axis from nose out to tail. The longitudinal axis in the Airbuses. The side stick left and right. You can see how fast it acts. It's the ailerons and the spoilers in the Airbus aircraft. Ailerons and spoilers left and right. Turns using the side stick left and right like this. In the Boeing you have the control wheel over here. Is the same function like in the Airbus. You make left and right turns, no difference at all, as you can see. So left and right turns using the control wheel over here in the air. And also we climb and descend. We can use all flight controls together simultaneously, have coordinated flight. So side stick left and right in the Airbus, control wheel in the Boeing. So in the Boeing also we have ailerons, spoilers, and one flapper on here, as you can see is moving. So you can see the ailerons over here, also the spoilers and the flapper. So this creates aerodynamic difference between the left and the right wing, aerodynamic lift difference, which makes the aircraft turn in flight. So this is all flight control. We have also the horizontal trim. We can extend this, slow down the aircraft. The speed brakes, also flooding. So I'm gonna show you one more view of the flight controls of the Boeing 787, and then we proceed with the flight management computer and the rest of the systems, the autopilot and the screen. I'm gonna make an engine start demonstration, so I will show you this nice view now. Hope you're gonna like it. Again, you can see the computer I'm using and the mouse pad. I have the keyboard and the side stick that is identical to the Airbus side stick. So I'm gonna show you this view over here and also the screen view. So you can see we can climb and we can descend the aircraft. Over here, hope you like the Airbus style side stick and the Boeing yoke over here. So we have both. So we climb and we descend. We make turns to the right, turns to the left over here. No difference at all. All flight controls work the same. So we can climb, we can descend, we can make turns to the right, turns to the left over here. You have the horizontal tail trim stabilizer that I talked to you already about. And also we have the thrust control over here. We can use the thrust for the engines, moving this slider back and forth. You move the engine's thrust commanded over here. As you can see, the engine's thrust. So hope you like how we control the aircraft. Climb, descend, side stick back and forth. You can see the side stick deflection is proportional to the yoke deflection, the difference. So we see also the outside view, climb and descent, rudder over here, rudder pedals, and also nose wheel with the rudder pedals, and also ailerons and spoilers very fast. You can use all together, all flight controls. Make turn and climb like this, for instance. So you see the elevator, how it works. So hope you like this view of the aircraft we use for flying. Climb and descend, make turns. You see both sides in the cockpit of the Boeing aircraft are interconnected. All flight controls and rudder pedals, also the Airbus rudder pedals are interconnected. So the side stick, as I talked to you, Airbus has side stick priority or dual input. The Boeing has only dual input, but you can override with some force one side on the Boeing aircraft. So this is all flight controls for now. Hope you like. Also the engine thrust over here. Oh. So we go now for the rest of the systems over here. As you can see, so turns, climbs and descends like this. So now the rest of the systems, we go for flying. We need to set up the flight management computer over here. So I'm gonna set up the flight management computer. I will show you how. I will input all the data of the aircraft for this flight. Then I will set up the autopilot flight director system panel and show you the screen. You're gonna make an engine start demonstration. So you're gonna see now having the mouse pad here and the keyboard. So I'm getting control over here. The inputs that I need to make for the flight management computer. So the flight management computer here, you're gonna see all the data needed. So you're gonna have also the mouse pad here. As you can see, you're gonna input all the functions and the keyboard, the screen, so you can use the mouse pad. You can see identity, position, performance, takeoff, annunciate, approach, annunciate status, navigation, data, traffic control. So we go here. From this view, gonna set up. Oh, you can see also we have another aircraft coming for landing right now. Hope you like it over here. It's another Boeing 737. So we're going up for this view over here. So we have identity, position, performance, takeoffs, identity, Boeing 787-900 aircraft, the NX engines, the index, position. We can set the inertial reference position here, align the GPS and the IRS alignment, the laser gyroscopes that align us with the magnetic North Pole, geographic North Pole, performance, zero fuel weight, fuel on board, gross weight for takeoff. Also we have cruising altitude, cost index, reserve fuel, fuel freezing temperature, and the center of gravity in flight. So we're gonna use departure over here and arrival, origin and destination. You can copy paste over here, origin, destination, like this. Clear the discontinuity here later. So we use this runway 14 departure. We select departures here. Runway. We use also the screen here and the keyboard. to press some buttons, as you can see. So we use runway 10, 1416. This side you can see 2832. So we select runway 14, and the seats are the southern instrument departure, waypoints and fixes, and horizontal vertical navigation fix and altimeters to come straight. So we use departure again, arrival page. So we complete the flight plan. We use approaches VOM 162834 ILS 14 ILS 16 over here. Next page ILS 28 ILS 34 GLS 14 localizer 28 localizer 34. So we use ILS 14 over here, Transamity over here, and we use over here stars the southern terminal arrival weapons fix Negria 1 Alpha over here. So we have departure arrivals over here. The route is set, we see with blue, nice active route. First waypoint to Nazca Mars heading 1, 2, 3, 5, 6 Zui. We climb, make left turn, right turn, descend, approach and landing after the Nigria. So you're gonna see 0701 the approach. So we set a couple more things over here. We have zero fuel weight 322.7 thousand pounds, fuel on board 34,000 pounds, gross weight 356.7, reserve fuel 5%, cruising altitude 25,300 feet, like 8,000 meters, and the cost index 100%, fuel freezing temperature minus 37 degrees, center of gravity. So we press this green execute lighted switch here. It will activate the flight plan of the aircraft. Now we can use the autopilot to follow this route, this flight plan or flight path. So we have the first waypoint after takeoff, 136 degrees to Nazca Mars 250, 1,900 feet above the sea level, TRO nautical mile. We make a left turn 3 nautical mile, 5 nautical mile to Zui, 5 heading 0526 nautical miles, 301 knots, 6,000 Alpha. Then we climb to the Nigria heading 071, 26 nautical miles, 301 knots, flight level 22,200, like 7,000 meters. Make a right turn at 230 heading 12 nautical miles from Nigria, 320 knots, 11,800. So here we descend, make 6 nautical miles, Zui 9 nautical miles, 7,000 feet. Zurich 7001, Zurich 701, 6 nautical miles from Zurich, 186,000 Alpha. Then we descend TRA 10 nautical miles, COI 14, 6 nautical miles, Osnem. We make a left turn here to align with the runway, also align with the ILS localizer, 5 nautical miles from the runway, 100 from the COI 14. 174,000, also runway 14, approach landing 8 nautical miles, 140, 1,430. We have also takeoff to run. So we set the flaps for takeoff, center of gravity, runway position, V1, V rotate, V2 with this gross weight over here. We can also use departure arrival, alternate VNAV progress, VNAV and progress. Also hold, we can hold, select a waypoint and hold over here in flight, fix, and also use a navigation radio for ILS localizer, for NADF. So we have the route here, active route, as you can see. We need to see a couple more things before going into flight. So we have a few more minutes. You can see now the route is activated here in the computer screen. So it will display here in the navigation display, also in the HSI. You can see the flight plan, the horizontal and vertical. You can see the terrain with amber, yellow, green, red, the radar scan. You can see in the vertical how far above the ground we're going to be flying, also the autopilot and the other displays. So we're going to use the autopilot. You're going to see how. I'm going to show you also make an engine start demonstration. So we have here the displays. You can see here we have the airspeed indicated, 30 knots. The airspeed selected from the autopilot flight director system panel, 200 knots. The radio altitude above the ground 2 feet right now. It will display 2,500. The altitude indicator with the artificial horizon, pitch ladder in degrees. You can see 2.5, 5, 7.5, 10, 12, and a half, 15, 17.5, 20 degrees for pitch up and pitch down. Also the bang roll in flight. we can turn like 5, 10, 15, 13, 45 degrees in flight. You can see the barometric altitude above the sea level 1430 feet with this barometric pressure 29.92 inches of mercury or 1013 hectopascals. We can increase and decrease the altitude, barometric altitude setting, inches of mercury 1013 hectopascals or 29.92 inches of mercury will increase or decrease the altitude displayed. We can use also flight path vector meters, radio barrel minimums. This plan rates weather radar, traffic and terrain on the displays for the display over here of the map mode, also the flight plan, the terrain and other aircraft. We have accept, cancel, reject, some warnings. We have the systems display here, CDU info, checklist, communication, A for ACAS, cancel. We can see other systems here and also see expanded map view. Also gonna see now the barometric pressure that I told you. We can see also the vertical barometric altitude and the target altitude. We can see also the airspeed from empitode, static, empitode, dynamic, vertical rate of climb of the aircraft, vertical speed indicator here. We can see like 500, 1000, 1500, 2000, 3000, 6000 feet. When we climb it will show us this needle move up. When we descend, this needle moves down. Flight mode on 0 with the autopilot. Now it's takeoff ground. Also the flight plan here you can see on the edge side the first waypoint and the runway used for takeoff and for landing, the ADF left and right. So we have magnetic heading and the distance 18 nautical miles. If we look closer, you will see in the map or further away you can see more airports like 100 or 320, 160. You will see more airports here. So I'm gonna use the airport now instead of the waypoints. So you see the airports are displayed. You can see the France over here, the Germany on this side, and also the Switzerland here. The terrain elevation 4,600, 5,200, 1,600 minimum, 5,200 is with the red. So we look closer, you will see here is the Düsseldorf EDTL is just heading in front of us. 329 right now. EDTL is in front. Also you can see the mountains, the terrain. I will talk to you now, in the runway, the taxiway here in the runway. You will see them displayed in the display here. So we have the Düsseldorf airport, our own airport. We can fly in the air. You will see the flight plan. Also we will look closer. You can see more of the flight plan with this purple magenta line. Also how we climb and the terrain. You can see when we fly the terrain below us and in front of us. Here is around you and in front of you. And also we have the runway here we can use for takeoff and for landing. Also you can see the terrain, yellow and green, and the aircraft symbol, this triangle. When we fly we have to make an avoidance of the terrain. If we look closer, we have the runway here. So you can see the runway, the taxiway, the runway, also center the whole airport here view. So this is same like outside. You look here, you see the airport. So we go now for the rest of the systems. If we look the other view over here, you can see the aircraft symbol and the runway for navigation, map setting. Also, so we look a little bit further like this. We'll see again the waypoints and the flight plan we have created over here, how far away we want to see other airports. Also I'm gonna use this map view for now. Also set up autopilot flight director system panel over here. Panel turn on the APU over here. We have the left and the right IDC, 120, 200 volts for 100 frequency, the battery, APU generator. Also we're gonna use 120,000 kilovolts, these contactors. We have the primary flight control computers in the auto position, air data computer, flight control surfaces, the battery towing power, FT door, oxygen over here, passenger oxygen, window sheet, rammer turbine, left and right engine driving, and electric C1 and C2. Off position, you will see what they display. They're in the fault mode right now, so this is the engine driving. Pumps will turn back on like this, and then to the auto position, primary demand. Electric C1 and C2. We have wing and engine RDIs over here on our auto. We have the cabin pressurization that admits pressurizer from the engines in the auto position. Also in the manual, we use the outflow valves to pressurize the cabin as we climb or as we descend. Also we have the air conditioning, ventilation, oxygen, the packs from the left and right engine from the APU. So we have also the recorders, the cargo and APU fire control over here, electronic engine control for the engines with the auto start. Other controls the farex. Also we can set the auto start switches like this and start the engines. Fuel jettison, we can dump some fuel in flight. We arm the switch to knock the nozzles and how much fuel to remain. We have the left and right engine, wing, fuel tank, and the crossfeed valve is off. We turn it on, you can feed either engine with other pump or either tank and balance the fuel between the left and the right wing. We turn off the fuel booster pumps like this. So we have also, this is all the systems we need to know for the overhead panel. We have also some lighting, windshield wipers over here. We have also, here you have the fuel control, left and right engine, the auto throttle, disengage switch, the takeoff, go around, the thrust reverse, fuel control, left and right engine, fire extinguisher, left and right engine, transporter, rudder, trim over here. So I'm gonna show you the displays here. What they display before we're gonna make an engine start. Demonstration will go to full flight in a couple of minutes. So we have the systems over here. You can see hydraulics, the pressure, the display of the data. APU is running, the data of the APU, the oxygen, liquid cooling, oxygen pressure, electric, left and right IDG, 120 to 200 volts for 100 Hz frequency, 130,000 kilovolts. The APU, main battery, charge and discharge, and voltage and amperage in the APU battery. So we have also hydraulics, where the hydraulic fluid goes, which systems use hydraulic fluid. As you can see, also you can see, hope you have a better view. We have the left and right engine, primary demand, set-off valves, isolation, also the quantity of hydraulic fluid in the tanks, and also the pressure, 5100 psi. So we have the fuel, left and right, wing fuel and center tank, low and high pressure fuel valves here, the left and right engine are open. The crossfeed valve is off. We turn it on. You can feed either engine with either pump or either tank. We have 11,000, 11,000, 11,000, 33,000. We have balance between the left and right wing. The APU is fed from the left wing using the DC motor. Also, we can see the minimum fuel temperature below which the fuel will freeze. It's minus 37 degrees right now in flight. So the farex transfer, you can see minimum fuel temperature minus 37 and fuel temperature right now minus 6. So the farex transfer automatically the fuel from the wing tanks, left and right wing, into the engines to heat up the fuel in flight. Also the lubricant and the oil. We have the fuel, we have the recirculation fuel. We have also the packs, the pressurizer from the engines and the APU, cabin pressurization, oxygen. We have the doors are closed, the cabin can be pressurized, the gear, the temperature of the brakes, and the pressure of the tires, flight controls. Over here we move our flight controls around. You will see the tail, also climb, descent, the limits, and also the stabilizer trim. We have extended the spoilers. Right now you can see F is display over here. Also maintenance systems menu and circuit breakers over here. So we go back, we have the checklist, normal menu, what to do before start, after start, takeoff, approach, descent, approach, and landing. We go back, navigation display here, turn off both engines, so both fuel control, in the off position. You will see what will give us. We have fuel starvation and the engines go off right now. So we will be airborne in a couple of minutes. So we go over here. We need to restart both engines very quickly, as you can see. So both auto start like this. You can see the amber switches lights on for the auto start system. Now we have pressurizer into the engines. The N2, which is the high speed starters, have high press compression tube, and the tube which is the engine above 20%. Over here we can let the fuel flow. So now we have only pressurized air, we have no fuel over here. So we let the fuel control both left and right. So the auto start turns on over here. Fuel control, fuel pump, left and right engine driving. So the N1 is the low speed starters, have low press compression to one of the turbojet engine. Exhaust gas temperature, fuel flow. So the engines are on. Gonna be running in a couple of seconds. You're gonna see the green display running 61%. So here we go. We can set the autopilot here, auto throttle left and right. We have the airspeed also. You can set. For flying the aircraft. We have also the LNAV and the VNAV like this. You can set like this. If we turn off autopilot, flight director off, the modes are turned off. We need to re-engage, autopilot disengage. Also we have the bank angle limit and the heading. We're gonna set the heading of the runway here for this flight, 136 degrees vertical speed. We can leave to 0, we can descend, or we can climb like this. And we use this switch. So we're gonna be climbing. Also use the altitude. We can use thousands and also hundreds of feet. So we're gonna climb, like we're gonna take off right now. Use flaps for takeoff, speed brakes disarm. So we advance the thrust levers over here and parking brakes off. Take the clearance from the air traffic control over here for takeoff. So we align here with the runway heading, as you can see. So we use the tiller again for alignment, like this, as you can see. So we advance the thrust levers over here to take off, go around to position, or we push the side stick or the yoke down, align with the rudder pedals. So at 80 knots we let the yoke up, release the yoke. So we have 80, 90, 100 aligned here with the rudder pedals. So 120, 130 V1 over here. We rotate, picks up slightly, as you can see. So we have the takeoff rotation, and we climb. We have the positive rate of climb over here. Let it gear up as we depart the runway. So here you can see the displays. You can see we are 2,000 feet above the ground, like this. 2,100 feet, but 3,900 above the sea. You can see difference between ground and we have the airspeed 90 nautical miles. The pitch altitude here we have to keep low. The stall speed, wind direction, we climb with 4,500 feet. Flight director, also the terrain, red, green, yellow. The flight plan, the vertical, also the engines indication. We can see we fly above the terrain, 4,000 feet right now above the ground level. So we keep climbing like this. I'm gonna see one more view here a little bit further. You see more terrain, red, green, yellow. Indication, also look closer. You will see the terrain scan. We have the stall speed warning, so the terrain scan here. You can see we are 4,000 feet above the ground, 5,000. You can see the aircraft symbol. This green line is the terrain below us. We need to avoid 10 nautical miles, 20 nautical miles. So we're gonna start making turn now. As you can see, as we fly. So we depart the Switzerland here, the airport. We need to make the turn here. So we start turning for alignment with the flight one. And we have 15 more minutes for this flight to finish. So we overflying the runway here, keep climbing, flying manually. As you can see, we can leave the hands off from the side stick anytime, no problem. Change the view here. You can see both sides as we flying. You can see the airspeed 155 and the stall speed. Right now we climb through 12,000 feet, wind to 5 through these waypoints here, as you can see. So make a small correction here to the right. We leave the hands off, only the aircraft can do that, an airplane flying like this with the hands off. And keep its attitude. So we have here the display in Switzerland. Very nice view over here. Hope you like the view of the Boeing 787 as we are overflying. So we overflying here. Hope you like this view of the galaxy, also the moon. We have also the Switzerland, the lakes here. We're gonna be overflying Germany, my homeland, and France. So we're going with these vectors here. Make a small turn over here. Keep climbing. Maybe we need to apply a little bit more airspeed later. So you have the view here of the cockpit just after takeoff. You can see inside. Hope you like what you see. We have also to fly through these waypoints here. As we can see, we need to be aligned for if we need to use the autopilot for like a couple minutes maybe. Align first with the LNAV function, then use the autopilot engagement. I will show you how we can fly using the autopilot connected if we need to fly using the autopilot engaged. So we keep climbing. need to be aligned with these waypoints here. This flight plan, as you can see. Also the autopilot engagement. You will see in a couple of minutes what we're going to do. So maybe we're gonna engage the autopilot just for display. Turn on the auto throttle and use autopilot in the LNAV mode. Also Lszh. So now we have the autopilot engaged over here, as you can see. Hope you can see the autopilot is engaged. You can see here AP on the airspeed and the altitude, LNAV and vertical speed modes. So now we're flying with the autopilot engaged. We're gonna be flying through these waypoints. So we increase the airspeed also over here. And we use flaps a bit up. We make also the turn now. We have to turn back to the airport like this. As you can see, we overflying here the France, Germany, my homeland, the lakes, and the Switzerland. So we're going to use the override here. We can override one waypoint and press the execute button. It will turn us back to the airport like this automatically, using the autopilot only engaged. Right now, as you can see, we have no flight controls. Use only the autopilot now. So maybe we increase the airspeed. As we turn over here, overflying the lake with the autopilot on, engaged. Need to increase the airspeed. So we overflying here the lake, the Switzerland, the Germany, and the Swiss lakes. And we need like 8 more minutes to go back to the airport. So we're gonna be accelerating over here. So the other pilot will hold the aircraft like this as we're flying. As you can see, the altitude. We have the autopilot engaged. You can see the airspeed, vertical speed over here. We keep climbing. We need to accelerate. More airspeed. Leveling off maybe here. So you can see the AP on over here. We need to calm down for landing in a couple of minutes. So here we overflying. You have the most beautiful view here. We have a few minutes to go back for landing. We can set the autopilot for descent now. and the airspeed and flight level change. We're gonna have also vertical speed. Minus 7,000 feet per minute. We're gonna descend, idle thrust and speed brakes. So here now we descend. And we have 5 more minutes overflying this most beautiful view to go back to the airport before the video ends. So we take manual control if we need, increase the rate of descent over here. So you can see the airport we're gonna be flying through over. As we are descending, we have to follow these waypoints over here. As you can see this arc we need to descend over here. Also you see the cockpit view one more time, just before going for takeoff now. For landing actually now. So you see the runways that we have to use for landing over here. Maybe we have to do some shortcut to get faster into the airport. Keep descending. So we're gonna start our turn now over here, as you see, descending. This is the turn for alignment with the runway heading. Use left rudder over here to align. And we need to align with these vectors over here. So hopefully we're gonna be land in 2 minutes only. Auto throttle also off. We take manual control of the thrust levers. Auto throttle. Because the auto throttle maybe not functioning the way we want. So we start the alignment now with the runway. Also landing gear. Down in a couple of minutes. Gonna use some flaps. Landing gear down. So you see here that we are for alignment with the runway for landing. landing gear also, and flaps, full flaps down. So now we have manual, full manual flight controls. We increase the rate of descent like this as we are descending for the runway. So you can see also the Lszh localizer that we have here. So we're going to be using a little bit more thrust for approach and landing, to use a little bit more. Aligned with the runway, we have some side wind, some wind cuts, and to use cross controls here. So the touchdown here